Let's look at these pictures right here of these graphs to get an idea of what we mean by an improper integral. So look at the first one here. What we're going to do is we're going to take this curve, 1 over x squared, and just find the area bounded right here between 1 and 2. All right, so it turns out, okay, if we did this, you know, we could actually do that, right? We could do this. We could go, what is the integral from 1 to 2 of 1 over x squared dx? And if we actually did that, we would come out with 1/2. Now, what if we did this one here? Let's go from 1 to 10. Just push this area out. Push this out. Let's go from 1 to 10. So we could do that. We could do the definite integral of 1 over x squared dx from 1 to 10. Find that area. That turns out to be 9/10. So this area right in here on the left, that's 1/2. Push it out from 1 to 2 to 1 to 10, and then the area has grown to 9/10. Now push that right-hand limit out even farther. So that's this down here. Start from 1, and instead of going to 2 or to 10, push it all the way out to 100. So if we found that, we would go from 1 to 100 of 1 over x squared dx. And that turns out to be, if we actually did it, 99 over 100. And then let's do one more. Suppose that we take this right-hand endpoint. You know, we started here at 2, pushed it out to 10, found the area, pushed it out to all the way to 100, found the area, 99 over 100. Now push it all the way out to, where are we going? Just some number b. All right, so we just find it out to b. So if we actually did this, just like we did the others, we would have this. The integral from 1 to b of 1 over x squared dx turns out to be 1 minus 1 over b. I think it might be a good idea to actually show that one. This is going to go from 1 to b of, let's write it x to the negative 2 dx. This is going to be 1, well, we don't need that. Let's just go ahead and do this. This is going to be x to the negative 1 over negative 1 from 1 to b. I'll put the negative up and bring that down. This is going to be negative 1 over x to the first from 1 to b. Put in the upper limit, we'll get negative 1 over b, minus, put in the lower limit, we'll get negative 1 over 1. So we get negative 1 over b plus 1, or if I just switch those, we get 1 minus 1 over b. Now, let's use this idea here and get some room here. So here's what I'm going to do. I'm going to erase this stuff right here. And then let's see what happens if we push b out even farther. All right, so we pushed it from where? 1 to 2, we got 1/2. 1 to 10, we got 9 over 10. 1 to 100, we got 99 over 100. Then we took it out to some arbitrary number, b, and we got this expression right here. So now, why don't we just take b out farther? Let it go to infinity. Take it all the way out to infinity. So what we're looking at here now is this. What is the limit, then, as, say, b goes to infinity of 1 minus 1 over b? Well, this is going to be the limit as b goes to infinity of 1 minus the limit as b goes to infinity of 1 over b. This is just 1, right? As b goes to infinity, 1 is just 1, minus, well, as b goes to infinity, 1 over b, that's a fraction. As the bottom gets smaller and smaller, the whole thing gets, as the bottom gets bigger and bigger, the whole fraction gets smaller and smaller and goes to 0. So that thing turns out to be 1. So then what we've said is this. So the integral, the area under the curve from 1 to infinity of 1 over x squared dx, that turns out to be the limit as b goes to infinity of 1 to b of 1 over x squared dx, and that turns out to be a 1. Let's just take a quick look at that again. So we're looking at this one here. We want to see what happens as we go all the way out to infinity. So we're looking at this. 1 to infinity, 1 over x squared. Well, that turned out to be the limit, right? When we went down here, we got 1 over b, and then we took the limit, and we got a 1. So this integral is just the limit of this integral. This is a proper integral because I have a lower limit and an upper limit. This is improper because one of the limits is not a real number. But it turns out that if you take, it's just anti-intuitive, I think. If you keep going and going, seems like you're getting more and more area, but as you go all the way out to infinity, that total area under that curve turns out to be exactly 1 unit. So we're going to define improper integrals like this. We have 3 different types. This one here, that's the one we're going to look at, and this is the only one to which we are going to pay any attention. Because in most applications, we are just looking at positive numbers. We don't need to go to negative infinity, like what happened long in the past, or what happens long in the past till long in the future. This is maybe starting now, going off into the future. So our definition, we're not really going to use these. We're just going to use this one. So if we have an improper integral, meaning one of the limits is infinite, if we go from some number a to infinity of f of x dx, that's going to be the limit as b goes to infinity of a to b. So we're going to actually write an upper limit here of b and then see what happens as b goes to infinity. We'll do some examples here. Let's look at this one. We'll use this as an example, but it's actually question 1 out of the homework set. What we want to do is go from 3 to infinity of this curve right here. Now this curve, I'll just give you a basic idea of what it looks like. It looks kind of like this. All right, and we're going to start here at 3. All right, so we're going to start at 3, and then we're going to go all the way out to infinity, right? Just keep going out toward infinity, right? Infinity that way. And what we're looking to do, even because this is continuous and non-negative, we're actually finding the area under this curve all the way out to infinity. Now, I know it's not intuitive. It just seems like, okay, as we go out, we're adding more and more area. It seems like the area should become infinite, but sometimes our intuition is not reality. Let's see what happens. So what's going to happen here is we're going to convert this to this form right here, right? What do we have? We have from a, our a is 3, to infinity of some function dx. We're going to rewrite this integral here like this. All right, so let's do it. We're going to get our integral, the integral from 3 to infinity of 1 over x cubed, 1 over x to the 4th, dx. That's going to be the limit as b goes to infinity of the integral of 1 to b of 1 over x to the 4th dx. I'm going to rewrite that as, so to evaluate this one, I'm going to rewrite that with that, bringing that x up to the numerator. Let's take the limit as b goes to infinity of the integral of 3 to b, x to the negative 4 dx. Continue on, we'll get the limit as b goes to infinity of, now integrate, anti-differentiate, x, this is going to be x to the, increase the exponent by 1, negative 4 plus 1, negative 3, divide by that new exponent, negative 3, and we're going from 3 to b. But let's just write that without a negative exponent, so I'll do it up here. We're going to get the limit as b goes to infinity of, okay, I'll bring the negative up, and we'll get 3x cubed down here, and we're going from 3 to b.